I'm delighted to welcome my first guest onto the stage, Gunnar Steitsch, Senior Vice President, Head of Engineering Engines at MAN Energy Solutions. Gunnar leads on R&D and development of engines and sustainable fuels for cargo shipping vessels and offshore energy storage. So couldn't ask for a better person to talk us through fueling the future of green trade. Gunnar, over to you.
Thank you very much, Richard. Good morning, ladies and gentlemen. I'm happy to be here and elaborate a little bit on how we at MAN Energy Solutions see the maritime energy transition and how we are working relentlessly to make it happen. So MAN Energy Solutions is a part of the Volkswagen Group, and with some 14,000 employees and 3.3 billion revenue last year, we are active at 100 sites globally, as the marine business is truly a global business. Our company is centered around three pillars: the marine business, mainly with 2- and 4-stroke engines for large ocean-going vessels, power business, and industries, and all this supported by a global after-sales network, which we call MAN PrimeServe. And all the three pillars of our company are really centered around the strategy of decarbonization and sustainability. And why is that the case? Well, roughly 90% of volume of all goods is traded around the world by marine vessels. And this contributes to roughly 3% of the global CO2 emission. By the way, similar order of magnitude as the entire country of Germany. And with our market position in marine engines, we can claim that we are responsible for approximately 50% of the power covering the world trade. And the IMO, International Maritime Organization, as the governing body for marine regulations, they have set a CO2 and a greenhouse gas reduction target by 2050 of 50% on an absolute level, as the trade is expected to grow on a relative level. That is actually more, that is around 70%. And with our share there, we certainly do have a very big responsibility, changing this to the better. But it's not only the responsibility, it's actually also the business potential we see in this. So what are the drivers for CO2 neutral shipping? It is for sure regulations, because the new fuels that we will be talking about are more expensive and will stay more expensive than at least we have been used to in maybe not the recent month, but the recent years. And the main governing bodies here are the IMO, and they have introduced this overall target, 50% absolute, 70% relative CO2 reduction by 2050 per transport works. And what is in place there as a more specific set of regulations is a so-called design index, which rates the efficiency of the vessel design compared to other vessels in the fleet. But then there's also an operational index, the CII, which rates the way the vessel is operated and whether that is efficient or not, and how much cargo it transports on average compared to the rated amount of cargo, and so on and so forth. So far on IMO, there is only a so-called tank-to-wake approach. Similar in the car industry, this is probably tank-to-wheel. We call it tank-to-wake, but it means that only the emissions at the funnel are looked at. But this is actually not enough, and also IMO has realized that, and they have the intention to change that to a well-to-wake approach, to a life cycle approach of the fuel, and this is actually very important. The European Union last year has announced their Fit for 55 package, and a sub-program of that is the Fuel EU Maritime Program, which is planned to come into force by next year. And this is actually more ambitious than the IMO targets, and specifically it also looks not only at the overall efficiency, but it specifically targets to change from the classic fossil fuels towards more sustainable green-produced fuels. And they have set an increasing target. It increases year by year, and by 2050, a 75% greenhouse gas reduction is intended here. We should, however, and I mentioned that earlier on, we also see the business potential in this. We should not underestimate the market request. There are customers already now that are willing to pay a premium to support carbon neutral transport and support their own sustainability targets. And, well, we are providing the technology. We are not providing the transport itself. So we are here in second line, but what we see is that there are customers who are willing to pay a premium for those carbon neutral transports. And last but not least, it's the cost of the fossil fuels. There will, of course, always be a competition in price and cost, but with the fossil fuel prices skyrocketing as they have in the recent months and weeks, actually, then we see that the cost of the green-produced fuels is not out of reach anymore. It becomes viable. And in fact, 2 weeks ago, there was a press release stating that for the first time ever, green-produced hydrogen, so produced from renewable electricity via electrolyzers, was more cost-effective, cheaper than conventionally produced hydrogen made from natural gas. So this is first time ever, and I think things are really changing here. So what are the fuels we are talking about? We start here on the left-hand side with the classic fossil diesel. Biodiesel, of course, is relatively similar, but probably not enough, not available in sufficient quantities. Then we have liquefied natural gas as a transitional fuel. I will show later that many ship operators are selecting this fuel right now, and of course with a vision to later on shift to synthetically produced natural gas, which can then be produced in a green way. But there's also methanol and ammonia, if produced in a green way, that can be carbon neutral and that will be really attractive. Hydrogen on the right-hand side is for the deep sea long distance shipping rather a theoretical option at the moment. And why is that the case? We have shown in this graph on the gray bars maybe the most important, the energy density, or in fact the inverse of the energy density. It's the tank size you need to cover a specific distance. With diesel set to 100% as the baseline, and then we see if we go to these new neutral fuels, the energy density decreases. You will need larger tanks, means you will probably lose cargo space on a vessel. And with LNG, you are a little below a factor of 2. With methanol and ammonia in the future, that will be a factor of 2.5 to 3. But with liquid hydrogen, it's a factor of more than 4, 4.5. And then on the red bars, we have also shown the boiling temperature, which is an indication about how much effort is necessary to keep a fuel in the liquid phase, because that you want to do, then it's more easy to handle and the energy density is much higher. And with hydrogen, it's minus 250 degrees, so that is a huge effort to keep it liquefied. And even if liquefied, it's still a volume factor of 4.5 compared to diesel. So we only see that for short-term, for short sea, short distance applications, but not for the long distance shipping. Really, the three fuels that look viable for the future is the synthetic natural gas, starting with fossil natural gas as a transition, and then methanol and ammonia. So how far in the future do we need to look? Actually, most of this is already available. And we have shown here a slide of our two-stroke main propulsion engines for large merchant vessels. And in the first column, you see the different fuel types, and then written in red, our different technology platforms that are all designed for a different fuel. And in the green fields, it's the design where the new engine, for which fuel the new engine is actually designed for. But then in blue, you can see retrofit options. And in most fields, actually, in this table, there's a retrofit sign indicating that there is flexibility. And later on, there is a possibility with moderate effort to convert from one fuel to another. And this is important. We have set up as modular as possible system. I'm not going into the details here how this is done, but basically, even if you build a new vessel with a new engine that is designed for, let's say, natural gas, then if 5 or 10 years later, it turns out that you would rather convert to methanol or ammonia, then this is still possible. And this is not in the distant future, this is now. We see here the vessels on most of these fuels are sailing already. Natural gas is widely used today, it's a standard, you can say, but also methanol vessels are sailing. Roughly 20 vessels have been sailing for 4 to 5 years. Ethane, LPG is sailing, and ammonia we are currently developing and expect the first engine and vessel to be available in 2024. Now I'm stuck in here. Can you maybe help me out and switch to the next slide? Here we go. So how fast is the uptake of the market of the new fuels? In this chart it's shown historically. The dark blue is the number or the amount of power in gigawatts delivered with conventional single fuel engines. HFO stands for heavy fuel oil. And then in the light blue, we have dual fuel engines. And these are the engines then actually able to operate on new alternative fuels. And this has been steadily climbing up, some 30% market share for dual fuel engines in order intake in the last year. And now it really takes off. And in the first quarter this year, the market share of dual fuel engines in new order intake was roughly 60%. So the transition is really taking pace now, and it's going to happen. If we then simulate, how is that, and this what I have just shown is the order intake for the new built vessels. But if we look at the entire fleet that is sailing and have in mind that on average a vessel is in operation for 20, 25, maybe even 30 years, then of course only replacing the oldest vessels with new ones with the new fuels, then it will take a lot of time to convert the entire fleet and to touch what is really burned today. And this simulation is shown here. Dark blue, again, the conventional fuels, and we see that if we only look at the new buildings, even in year 2050, still some 30% of fuel burned will be on conventional fuels. And then in the other colors, mainly it's LNG, later on switching to synthetic natural gas, but e-ammonia and e-methanol kicking in then around 2030. But this is certainly not enough. In order to really accelerate this, we don't only have to look at new build vessels, but we really need to look at retrofit, at conversions of existing vessels as well. And it has been demonstrated that this can be done. A number of examples shown here. Maybe the one on the left-hand side, a feeder container vessel, is especially notable. This vessel was born as a diesel-burning engine and vessel in the beginning. Then some 5 years ago, it was converted to run on natural gas. And at the end of last year, actually, it did the first trip ever based with green-produced synthetic natural gas, which can be just blended into the fossil natural gas. The engine won't notice a difference. In fact, it likes the synthetic gas a little bit better because it's even cleaner. And so it has saved 30 tons of fossil natural gas on this round trip, roughly 60 tons of CO2 on that one trip. But also other vessel types, very large container vessels, and also tankers and passenger vessels have been converted in the meantime, so it has been proven that this can be done. Yeah, to sum up, the maritime energy transition is driven both by regulations and by the market demands to transport goods in a more sustainable way. The alternative fuel selection is not obvious. The optimum depends on the applications. There are several fuel types possible, and in some applications the one has an advantage, in another application the other has an advantage. So we do expect that it is not a one-size-fits-all, but there will be in the future several fuels in parallel. And for that reason, fuel flexibility and the retrofit options are decisive, because the ship owner obviously wants to avoid stranded assets. And even if a vessel is sold after 10 years, maybe even to a different continent, where that fuel type may not be available, or another one may be more affordable, then a retrofit is possible. The natural gas is available right now. And with this, we reduce the CO2 footprint by roughly 20%. But this is, in the long time, of course, not enough. But as it is available now, and also the infrastructure in the harbors, in the bunkering infrastructure is available, then it seems also to be a good transitional fuel, because today you can run on natural gas, on fossil natural gas, and then continuously, as the new fuels become available, blend in more of the synthetic green-produced methane or natural gas into this. Methanol and ammonia are clearly the two other interesting fuels with zero carbon potential. What is needed to make all this happen is a CO2, or maybe better, a greenhouse gas pricing, to make those fuels competitive with the fossil fuels. And obviously, those regulations need to be globally harmonized, because shipping is a truly global business. And this is really a prerequisite to have a level playing field here. The critical factor is the ramp up of the production of e-fuels today, and especially electrolysis capacity to use renewable electricity from wind and solar power to split water into hydrogen and oxygen. That needs to be ramped up to have more of the new fuels produced in a green way available for shipping. The technology burning it on the engines, on the vessels, is there. And regarding ammonia, will be there in short time. But really what needs to be ramped up now is the quantity for the production of the green fuels. So with this, I would like to thank you very much for your attention, and I'm looking forward to the coming discussion. Thank you.
Gunnar, thank you very much. Fascinating insights there, really important intel on the roadmaps, the opportunities, the options available now and in the future. We'll get more into that in our panel discussion. Right now, please take a seat, and I'll welcome onto stage my next guest. So next up, we have Maiko Weissar, supply chain expert with over 10 years experience leading Siemens Energy European logistics, and more recently building the Ineos Automotive supply chain from scratch. Marco, I'm going to hand over to you. Obviously, we've just had some great insight on the maritime sector, but you're going to take a look at all transport modes as well. So I'll hand over to you, and then we'll come back for the panel. Thank you, Marco.
Thank you very much, Richard. Welcome to you guys. It's very a pleasure for me also being here as the supply chain expert, definitely not in the maritime world, and definitely also not so much in the e-fuel world. But the question, this is what we want to discuss in the next couple of minutes, is, this is what Gunnar also was saying, e-fuel production is not ready yet. I will go more into detail into that later on. But when green energy is not fully available yet, what can the logistics of an OEM or the logistics of a tier one, where I have also the experience, what can we do? Which contribution can we do to go down towards net carbon zero? This is very, very important. So let's dig into that, but let's go to the next page. Wait. Equipment is important. Good. So I look now to e-fuel from the, I would say, from the economic way, not from the technical way. And when you look e-fuel, how e-fuel is produced, e-fuel is always made of hydrogen. Of course, hydrogen liquid is also a kind of e-fuel, but every e-fuel needs hydrogen as one source for being used in combustion or whatever. During the production of e-fuel, there is energy loss, energy efficiency loss. For producing hydrogen, what do you need? You need electricity. Electricity and hydrogen, when you produce the hydrogen, you have also an energy loss of 39%. So just thinking about, you produce electricity out of oil, make an e-fuel out of it, so you burn oil to generate oil, but with the energy efficiency loss of 55%, and thinking then later on this in the combustion engine, then you have another energy loss of around 45%, because this is the heat going into the air and not the energy going into the wheels. That's actually, it doesn't make sense, to be honest. It really does not make sense. So looking to the available green energy, because then e-fuel is ready, looking to the available energy is 58%, unfortunately. These days we're discussing a lot about it, is out of oil and gas. A lot, 10% coal, 13% out of nuclear energy. Actually, discussions going on. Nuclear energy, is it green, not? Is gas green or not? I think every one of us knows the answer. And then 70% out of renewable energy. So these 70% in 2020, I think is now increased to something around 22%. In Europe, in the EU 27 countries, this green energy has in the future to serve the complete industry, the complete households, all the EV manufacturers, all the EV batteries going onto the markets, all the e-fuels produced. So that needs to come 100% out of renewable. How is it possible? It's actually impossible. And by the way, Europe as a continent, compared to other continents, will on long term always be an importer of green energy. We just do not have wind and enough solar, like, for example, South America, like Africa, like Australia, which will be maybe the big exporter of green energy, no matter if liquid, no matter if already as an e-fuel, as ammoniac or whatever. Yeah, they will be the future exporter of these energies, and Europe will always remain to be an importer. This is very sure, this is very honest. Yeah, do we have the infrastructure for it, for importing? Yeah, somehow, yes, but not really, not really. We are just starting this journey. We are just starting to look about how we can import green energy. It's not here yet, but there are plans. Producing green energy, producing e-fuels. Well, my old employer, Siemens and Porsche, they had a joint venture together with also other companies in Chile. They make e-fuel out of wind energy. The plant is producing this year already 130,000 liters of e-fuel for Porsche cars, for example, with a combustion engine. In the year 2026, they want to already increase to 550 million liters in Chile out of this plant. And what is 550 million liters? Divided into 20,000 kilometers per one Porsche per year, you have 3,000 cars which you can provide the energy, which you can provide the fuel out of it. This is basically nothing. So this power plant in 2026 can just serve more or less a village. Fuel for a village, for the cars for a village. Not more, not less. So the capacities are at the moment not here. There is a ramp-up plan, and especially the Ukraine conflict, I think this accelerated it a lot. I think also in Germany, with the plans to have, I think, around 10,000 megawatt capacity even in Germany, which is around 30 nuclear power plants, energy on e-fuels in 2030. Well, actually, is our plans, infrastructure need to be here. Also, infrastructure providing green energy, looking for the trucks, the number of stations for H2. I counted them last week. In Europe, we have around 160 gas stations for hydrogen. Out of them, 93 are in Germany. I do not want to show off for Germany. This is not my intention, but actually, where can you drive a truck, a hydrogen truck, and look for the next gas station? It's strictly impossible. Yeah? So I just can say to OEMs, which I also was before, and to the tier ones, which I also was before, take care of yourself, do something for yourself, and look, especially into inbound, where are the highest carbon emissions? And here you see an example on the left side. Exemplary, this is just the inbound transport. How does a average physical inbound transport at a, I would say, an average OEM look like? This is some estimation, former experience. I would say 90% is road. 90% the goods come in by road from the tier ones. 9% coming from other continents, normally by sea freight, and 1%, and the OEMs will laugh probably now. I think the reality is much higher. 1% is air freight. Yeah. Why does an OEM plan air freight? Of course, if the order quantities are very small, it's cheaper to fly instead of to put it into a vessel. When you have a LCL with 30, 40, 50 kilograms, it doesn't make sense. Of course, you need to do air freight or parcel or whatever. But look to this carbon emissions inbound for producing one vehicle by having just 1% air freight. How many kilograms, really, kilograms of CO2 are produced out of it? It's 338 kilograms. So when you are a car manufacturer, when you are OEM, or when you are tier one, you have to look to avoid air freight. And then you can do already a lot to reduce carbon emissions. That's the key message. Okay, but look to the air sector. So Gunnar looked to the maritime sector. And now let's have a look to the air sector. Gregor yesterday from Airbus probably could approve this slide or not. This is from the Airbus summit last year. A first hydrogen powered plane will be available by 2035. And the aviation industry will also reduce carbon emissions by 50% until 2050, and drop-in fuels, which are synthetic fuels, can replace kerosene. They are already now available. They wanna use it, and near drop-in fuels, which are not released yet, they will be also soon available. But as said at the beginning, it just doesn't make sense to provide e-fuel with burning something and instead take dirty energy for something which is clean. It just does not make sense. So what can a car manufacturer do? Well, first, avoid air freight, sorry. That generates the highest impact. I know some are old measures, some are measures which are maybe now new, whatever, yeah? And believe me, with the pandemic before and whatever, it's clear it's not always possible. With all the urgent freights, with all the unplanned situations we had in the past, no, it's not possible, but at least it's worth a try. So we have to replace, firstly, in the planning, air freight by sea freight, or air-sea combination, or railway combination. We heard just this morning, railway at the moment from China to Europe is also not an option. On long term, definitely yes. Very important is, when you have an urgent freight and air freight, which is not just because of a lack at a supplier or maybe a breakdown somewhere else, yeah, normally it's also because a not well enough planned pipeline, because the S&OP process is maybe not fully designed. So invest in your SOP process, then you can predict your supply chain much better, your production planning. You will have less air freight, and air freight is not only carbon emission, I think it's also money which no car maker wants to pay for, and also no tier one for sure. And of course, support of artificial intelligence is also very important. Yeah. What also do we need to have in the transport market? Predictive and real-time ETA, that you already can react before the goods arrive, before you have them physically there too late. And when it's too late, you need to do an air freight, that you have some alternative options to get the goods here without using maybe air freight. Yeah. Good, we need to have reliable standard freight lanes and vessels. Why do I say reliable? Sometimes vessels, you also know it, they sometimes go to ports by coincidence and whatever. They are maybe not reliable. Don't choose these lanes. Choose something where you can predict, where you know which are the next stations where they want to go. Yeah, also risk management as a strategic element in every supply chain department. In our discussions in the evening, the last couple of days or in the afternoon, well, I didn't see that a lot, to have a real established risk management. And actually a good risk management, maybe you can say yes or no, but that's what happens at the moment in China with the lockdown. That was predictable. If somebody knows the Chinese culture, if somebody knows the Chinese government, and how China is reacting to the pandemic and how the virus is going, you can predict the lockdown. And it's not at the end. So risk management is very important. Yeah, localized supply base. That means, and I think yesterday from SEMI we heard that a lot is done in the semiconductor area to localize semiconductors, for example, in Europe. That's good. Bosch, Infineon, Intel, whatever, they have, they plan factories over here. I think this is a good sign. We can do it with others. Yeah, insourcing. Sometimes do the things by yourself as a car maker, or alternative sourcing. Have a second source if something happens. I know, I'm very sure many of you guys have discussed this in the past also, but it's important to reduce air freight. Yeah? And if everything doesn't work, engage in climate compensation. At least plant a couple of trees for it. Yeah? It's not just to satisfy you and say, okay, at least I did something. No, put a price tag on it, invest in it, and also observe if the plants and the trees are really planted, and not just rely on something. Good. Next one. Improve road freight. I think there is still some space to increase fill rate in trucks, yeah, with good planning tools or lower transport frequencies. We also discussed it. Lean. Yeah? Lean does not mean slim. Lean does not mean starving. Lean means we have a good number of inventory so that we can react on things that may happen. So we need to have a kind of inventory in our plant and lower the transport frequencies instead. That helps us a lot. Yeah? Increase truck capacities. Here, I think the government is a little bit more to do than a car maker can do, but we can do some pressure. There are trucks available with 2 trailers, and they are running in Spain and probably also in other countries. So it's possible. Yeah? Put in more into a truck. The truck has almost the same carbon emission, and then you have only half of the carbon emission for the same load. That's good. Yeah, also within Europe, use intermodal or rail whenever possible, higher usage of collapsible packaging. And when you use collapsible packaging, please collapse them by bringing them back, not just keep them as they are, because they are collapsible. Okay, increase milk run rate, strictly operate TMS, and a TMS which can predict, okay, I pick up 1 day later, but then my truck is full. That's a good TMS system. Reducing supplier distances. That means a supplier already within Europe bring a little bit closer to the plant, but not with the cost that the supplier then has to bring the goods a little bit more far away. Then you didn't reach anything. So look to the global footprint out of the supply chain. Engage in climate compensation. Of course, also here, plant a couple of trees. That helps. And if everything doesn't help, and I think Jean Bricknell will also later on maybe talk about it, this is what I know from Volvo. Factor in the CO2 emissions in sourcing decision. Put a price tag on the CO2. And then go into a sourcing decision for a supplier and say, okay, supplier A in Brazil, supplier B in, I don't know, in South Africa. Look to the carbon emissions between the 2 suppliers, maybe supplier number 3 in Spain, wherever, and compare them. put the price tag on it, compare them, and then make the right sourcing decision, maybe based on a price where CO2 has a price tag. This is the things we can do. So everyone can do something. Don't wait for the government to do something. Everyone can do by himself or herself. And everything what the government is doing with e-fuels, with R&D, with regulations, with emission targets and everything, this is correct. This is absolutely correct and the right way. We have to go this way. And at the beginning, it's producing even more CO2, but at the end, we will get it back, and then we have the clean future. But okay, that's it for today. I thank you a lot. Hand over back to...
Thank you, Marco. And yeah, please do take a seat, and Gunnar, please come and join us as well.
Okay.
So fascinating to see that there's interesting roadmaps, there's complexities, challenges that lie ahead. Gunnar, something that you mentioned, the science, the technology is there, but what's the critical factor is the production ramp up. So what really needs to happen in terms of the investment and what are kind of some of the initiatives taking place that you're aware of and MAN are kind of working with and supporting to really drive this?
Well, it is, as I mentioned, the regulations, including a greenhouse gas price, are important to make this economically viable. And this is, but this is happening, and it is in fact happening quite fast. That the regulations come into place, and the EU Fit for 55 package is actually a suitable step into that direction. What regulators need to keep an eye on is that the different set of regulations are in line with each other and are not conflicting, driving different trends. But from our point of view, clearly the Fit for 55 is a way to support, is to go, and other regulations should follow suit and should align with this set. And then, as said also, market demand. I mean, not a long time ago, a large Danish ship owner, I think he's on the chart there as well, has decided to invest into a number of large container vessels running on e-methanol. And they have not only talked to us as technology suppliers delivering the engines, but they have also in fact set up a supply chain for the fuels on all the continents. And this is creating momentum now. And there are customers willing to pay a premium, and I'm convinced it will ramp up.
Yeah, interesting. And you mentioned customers willing to pay a premium. Again, that's something that's been a continuous thread that balance isn't quite there yet. We're not at the tipping point where the greenest solutions are the most economical, but there appears to be an openness and a willingness to see beyond the bottom line when it comes to these solutions. Let's move on in terms of that tipping point. When do you see that tipping point actually occurring, perhaps in maritime, but then in wider?
Well, in maritime or in general, I would say, of course, building up these production facilities and the infrastructure to distribute the fuel, that takes some time. We think that in 2028, 2030, it will have a notable impact, but it will start earlier. But with pilot applications, until it has a real notable volume, I think it will be another 6 to 10 years.
Okay. And Marco, from your perspective, and you mentioned a number of initiatives and things that people can be doing to action decarbonisation of the supply chain. From your perspective and your insight, just how big a role can fuels and future fuels play, and just how crucial is it that people kind of get on board with this, as well as undertaking these additional initiatives?
Well, as I said, there are initiatives ongoing with production of the fuels, within the provision of the fuels, and maybe just to your former question, maybe to add just one thing. In the future, also the green energy will always be in competition with the fossil energy. So even when the infrastructure is here, for producing all these fuels, for providing all these fuels and everything, the infrastructure for fossil fuels are still here, and they will compete. They always will have. They will always compete to a lower price than the others. So that is not a way. This is not gone. So we also need not only the government to support initiatives to build up the infrastructure. We also need taxes on fossil fuel, so that this fossil fuel in the future doesn't just make sense to import or to use. I think this is very important. And initiatives, what a car manufacturer, whatever, can do is really source the right partner, look to the right partner, that the right partner is looking on their global footprint, that they are looking that their fleet is in order, that the CO2 emissions are not that high, that they also test in technologies. And I think this is a good contribution they will do. We are all cost-driven. This is no way, and only when it hurts in the wallet, we do normally something. Before, it's nice to do, but when it hurts in the wallet, we are starting.
In terms of there being limited supply and obviously a growing demand for sustainable fuels, greener solutions, do you foresee a battle between the sectors, between the transport modes, and then equally between the end customers to fight for these? And is there a danger that this is going to increase the prices? The industry is already facing rising rates, seismic shifts in that respect right now. Is this going to exacerbate the problem and be the next pricing crisis?
Well, I'm not an economist, but I'm on the one hand side, yes, there will, at least in the beginning, there will be more demand for the clean fuels than the supply. On the other hand side, as Marco has mentioned, there will always be a competition towards fossil fuels plus a tax or whatever cost level on that one. So if that one stays lower, then there's also a force putting it down. And last but not least, I think we should also, to a certain extent, rely on the market forces. When the fuel prices for green fuels go up, then there will be more intention and motivation to produce these, then there will be more production. But of course, on the short-term side, there could be fluctuations, yes.
Yeah, interesting. And in your presentation, Gunnar, you mentioned a number of options. There's no single source. There's no obvious choice for the consumer. Is this a complexity from your side that adds complexity to the supply chain, or perhaps given the current situation, Russia, Ukraine, it's important to move away reduce the reliance on a single source of gas and things like that?
Well, it's a yes to both, actually. For sure, it is some complexity. First of all, you need to as a ship owner, you need to make a decision now. What are you going to invest in? Therefore, we offer flexibility, so maybe you can reverse that decision a few years down the road. But also, it may be the case that you have a certain set of vessels trading on several routes where you know that fuel is available, but on other routes that fuel may not be available, at least initially, and then you cannot use each vessel to go to every harbor, but you need maybe 2 sub-fleets, basically. So it adds complexity. On the other hand side, it also, as you rightfully mentioned, is a chance to reduce dependability on single sources, and it's always good to have more than one source, of course. And of course, that has also a cost to have several options. But it's more like I would see it more like an insurance cost. Having different sources that you can calculate very well in your planning. Having only a single source, as we are experiencing at the moment, then it's difficult to predict the cost, what will happen.
Yeah, of course. And Marco, someone who's built and supply chains from the ground up, your perspective on this, is this added complexity or kind of a welcome challenge right now, or is it come down to cost again?
I think yeah, it's, at the end it comes down to cost, but it's a complexity, but it's really something that in the DNA of a company. sustainability has to be implemented. It's coming back to this. It adds a kind of complexity, but I do not think compared to the complexity in designing a supply chain, this one is a big add-on. I don't think it is, but it's something that the people needs to understand and needs to be delivered in a different kind of mindset. By the way, coming back to the question with the Ukraine conflict, and I think that helped. And of course, in the future, when we have other exporters of these e-fuels, like Africa, like Australia, like probably South America or North America, I think then these situations, they will probably not happen anymore, that we are now stuck like this in this situation. But this is far away from now. It will probably take another 30 years or whatever until we are there, when we are lucky.
No, I don't think it will take 30 years. I'm quite optimistic it will go quicker, but it will also not happen in 3 years. That is, I agree.
Okay.
Yeah. I mean, and you know, sticking with the Russia-Ukraine sort of situation and Europe's decision to for less reliance on natural gas and from Russian sources, do you see this having short and long-term impacts? You know, Europe's roadmap itself to reduce reliance on fossil fuels, that's kind of all thrown up in the air right now. It throws an uncertainty. So how do supply chains, how do the car makers choose the right direction to go from here?
Well, in the short term, of course, there is obviously a need to replace gas coming from Russia, and then several countries like Germany are looking at LNG to import that. Also, what was mentioned earlier, I fully agree that Europe will not be able to produce enough own green energy. Europe should increase renewable energy production as much as possible, but it will not be sufficient. We will rely on energy imports in the future as well. And those imports will be coming from countries where there's a lot of wind and a lot of solar and a lot of space, maybe, like the Australian desert, where it's cheap to produce the electricity. And then coming back, it will be good to have more than one source in the future as well. Yeah.
See. And if anyone in the audience has a question, please feel free. Although we are getting close, this being the fuel session, I'm aware that everyone does need to be refueled themselves very shortly, so we will be wrapping up shortly. But perhaps I can just sort of close on something you touched upon, Gunnar, was the capacity on the maritime side, you know, with the tank sizes that are required. Capacity might be reduced. Is this going to potentially create future bottlenecks? And equally, as some of the ship makers and shipping lines have recently announced perhaps less aggressive targets in terms of their own decarbonisation strategies, is that further going to reduce the pool and the market size for decarbonised freight options?
No, I think this is, I don't see this as a threat. There may be some companies and some players moving quicker right now and others moving not as fast. But let's say when we talk to customers maybe 5 years ago, there certainly have been, talking to ship owners, there have certainly been some who probably just hoped that this entire thing about climate change would go away. This is not the case anymore today. Everyone has that clearly on his or her agenda, and everyone is planning with that. And yeah, the limiting factor at the moment is the green fuel supply, and I don't see that as a challenge if not all ship owners and all logistic companies jump at this at once, because there will not be fuel enough at once anyway. I'm convinced and I'm positive that once this gets moving and it is shown that it can be done, then it will create its own momentum.
Okay, fantastic. And perhaps, Mark, I'll come to you for final thoughts kind of on this panel. There's a sense of opportunity here, but a sense of work to be done. what's the key actions from your perspective industry needs to take right now to ensure that we stay on the right path?
Well, clearly, further support any initiative to further make even EV, more efficient. To make to think about the research how to produce more efficient e-fuels. To look about the infrastructure and also force the government to do something and to make regulation in place, especially in the EU. And also, when you choose a partner, look about what he's doing, and then this is the effect what you can do. And I said, look on your own supply chain, start with it, that you think also about CO2 emissions when you choose the right freight lane, because air freight, for me, is a no-go.
Okay, so we'll all be walking home, ladies and gentlemen. So
we are walking
with that in mind, we definitely need to fuel up ourselves. So I want to thank our panel, Gunnar, Marco.